Good morning. I mean afternoon. Where are you?
All right, our first parent function is going to be cubed. The equation is going to be y equals x cubed. For our x values, let's continue using what we used on Friday. So from -2 to +2. Now, when I'm cubing something, I'm multiplying it itself 3 times, right? Not times 3, but itself 3 times. So -2 cubed is -8. -1 cubed is +1. 0 cubed, 0, 1, and 8. All right, go ahead and graph those, and we'll see what kind of picture we got going on there. So I'm at -2, -8. Kind of looks like maybe wave-ish. -1, 0, 0, 1, 1, and 2, 8. Now, since we're just picking those 5 points, everything else is kind of an estimate. We're going to do our best, but we need to be sure we draw arrows at the end to show that those keep on going, but the party never ends. Now, since those arrows keep on going left and right, what does that mean as far as my domain? Okay, -infinity to +infinity. Well, what's another way of saying that?
Mister, that's not right.
That's not right.
Y'all dots aren't right in the the 30 yeah, you can graph those.
It's supposed to be -1 and 1, right?
Yeah.
Sorry, -1, -1. My bad. -1, -1. It did. Our range is the same. And what I was looking for earlier was all real numbers, right? I could say either one. We're all on the same page as far as graphing goes now?
Range is this way.
Range is up and down, that is correct. Alright, so we did quadratic and square roots on Friday. And that's the value. But if I'm going to do cubic now, then what's kind of the inverse of cubic? Cube roots. Yeah, so we're going to use that same root symbol, except this time I'm going to do a 3 instead of that understood 2. Yeah, I'll have to show you. There's 2 different ways to do it. Alright, this time we're switching our x's and our y's. So literally, all I want you to do is take your x's from cubic, put them where the y's are. So this is going to be -2, -1, 0, 1, and 2. Then my x's are going to be my y's from cubic.
In the equation, is that y divided by?
No, y equals.
Oh.
So I'm taking all those.
Why is the 30 outside the box?
It's on the, in the crevice of that root symbol. Because it's cubed. Alright, if I graph those, if I do it properly, I'm at -8, -2. -1, -1. I'm just plot the points that we said were correct. Connect my dots. What kind of shape we got going on there? Yeah, it's kind of like a slant. Very similar to the other one, to cubic. Alright, what's our domain going to be? Are we using all the x's? Do I have arrows? -infinity to +infinity. We need to be sure we say -infinity to +infinity. Go for it. -infinity to +infinity. And the range is the same thing. It's not 8, 8. No.
No, it's not. It's 8.
-infinity to +infinity. You can go now. Sir? Hey, Dad, you can go when we're done. Thanks, man. It does. Any other questions? All right. Next one.
I have a question. Hey, yo, Winston. So, is the cubic one right or is it wrong?
This one is accurate. -2, -8. -1, -1.
-1, -1.
0, 0. 1, 1. 2, 8. Okay, next one. It's called rational. And that equation is y equals 1 divided by x. Let's use these same x's and y's. Now this time we're going to be dividing our x's. So we have 1 divided by -2. 1 divided by -1. So if I put -2 in for x, what happens there? Yeah, -1/2. What is -1/2? -1/2, -0.5. How are you going to say it? Next one, 1 divided by -1 is -1. 1 divided by 0, we cannot do. No, we're going to write undefined, or I'm going to write the word whole. Undefined and whole mean the same thing, means we cannot graph it. It's a new concept we'll be covering this year. 1 divided by 1 is 1, and 1 divided by 2 is half. Go ahead and graph those and see what the shape looks like. It's kind of weird.
How do you do a 0 whole?
Nope.
Can you put that in a circle?
Just don't got it. Alright, so all I got is 4 points. Here's what this graph looks like. We're going to start up here. Go down like so. And we're going to start on this end and go down like so. One last thing I'd like you to draw in are these things called asymptotes. And no, I did not make this word up. Asymptotes are something a graph can get really close to but can't quite touch it. So I told in all my other classes that a couple years ago, my class decided to make T-shirts. On the back it said, "Nice asymptote, you can look but you can't touch." I get it.
So you can't touch mine.
Can't touch the line. You get really close to it. Our domain. Our domain is going to be everything but 0. 2 different ways you can write that. -infinity, 0, union, 0 to infinity. The other way to write it is, you can't read that, sorry. All real numbers, except x cannot be 0. That is the domain. The range is going to be the same thing, except instead of saying x can't be 0, what are we going to say? Yeah, y can't be 0. So I'm going to go over here. So we can go -infinity to 0, union 0 to infinity. Or all real numbers except, oops, I said it, but y can't be 0.
Okay.
Our next one is going to be the exponential.
What is that?
Exponential. Exponential. Y equals 2 to the power of x. Let's use our same x values. I'm going to move over to the right here so I can talk about a couple things. If I plug in -2 to get my first y value, this negative sign moves the whole entire thing in the denominator, but now there's no negative sign. 2 squared is 4, so my first value is 1/4. my next one. 2 to the negative 1. These are my exponent rules that you learned in Algebra 1. Move in the denominator. 1 over 2 to the first power is just 2, so 1/2. 2 to the 0.
Or 0.
Sorry. No flipping this time. Anything to the 0 power is
0.
2 to the first power is 2.
It's just 2.
And 2 to the second power is 4. These two right here, that's the negative exponent rule. So anytime you have a negative exponent, I'm going to move the entire thing down to a denominator, but I remove my square. Do you see the difference between negative 2 and 2? And I'm just squaring 2 squared, which is 4. Yes. Okay, graphically, so at negative 2, 1/4. Negative 1, 1/2. Kind of hard to tell there. 0, 1. 1, 2. 2, 4. Keeps on going and going and going. My next point would be 3/8 if I chose to do that. Keeps on going and going and going. My asymptote, then you can get really close to but not quite touch it, is going to be at y equals 0. So my domain, am I using every x value?
Yes.
Yes, I am. So our real numbers or negative infinity to positive infinity, however you want to write that. My range, am I going below 0?
No.
No, so everything bigger than that, please. Last one is the logarithmic. I'm just going to write log. Logarithmic. Our equation is going to be y equals log of x. That's the hope. I'm meaning it's cool later. Alright, our x values. Let's go. Negative 1, 0.
Mr. Van Cleef, when are you going to give us our calculus?
Hopefully tomorrow. 1, 10, and 100. Here's the part where we've got to kind of have a leap of faith here. Logarithmics, or logarithms I should say, are a complex idea. Complex idea that we'll spend about 2 weeks going over eventually. Right now we're just worried about what the graph looks like. We cannot take the log of negative numbers, so I'm just going to put an x through that one. Can't take the log of 0, so I'm going to put an x through that one. The log of 1 is 0. The log of 10 is 1. And the log of 100 is 2. Here's what this looks like. At 1, 0, got a point. At 10, 1, I got another point. At 102, I have another point. So my graph looks something like that. Keeps on going, 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 going.
What is the x meaning?
Means we can't do it. We can't take the log of negatives, can't take the log of zeros. My domain is everything bigger than 0, and my range is all real numbers. It will take forever and a day to get to all real numbers, to get to even 10.
This is one of the
Take forever.
asymptotes.
Asymptotes. As an asymptote at x equals 0.